Everyone, our lesson for today is all about special type of matrices and partition matrices, specifically diagonal matrix, identity matrix, upper and lower triangle matrices, symmetric and skew symmetric matrices, partition matrices, non-singular matrices, linear system, and inverse. To start with, in 1202, Leonardo of Pisa, also called Fibonacci, wrote a book on mathematics in which he posed the following problems. A pair of newborn rabbits begins to breed at the age of 1 month and thereafter produces one pair of offspring per month. Suppose that we start with a pair of newly born rabbits and that none of the rabbits produced from this pair dies. How many pair of rabbits will there be at the beginning of each month? This particular example could be solved using matrices. As we go along, we can determine that matrices is very important in solving mathematical problems. At the end of the lesson, you will be able to solve matrices involving partition matrices, differentiate singular from non-singular and invertible from non-invertible, apply singular and non-singular in solving matrices. Discussion: an n by n matrix A is equal to the square bracket of A sub ij is called a diagonal matrix if and only if A sub ij is equal to 0 for I is not equal to j. Thus, for a diagonal matrix, the terms of the main diagonal are all 0. Note that 0 is a diagonal matrix. A scalar matrix is a diagonal matrix whose diagonal elements are equal. The scalar matrix I sub n is equal to square bracket of D sub ij, where D sub ii is equal to 1 and D sub ij is equal to 0, for I is not equal to j, is called the n by n identity matrix. Now, to understand it, let's have example. Let A is equal to the square bracket of 1, 0, 0, 0, 2, 0, 0, 0, 3, and B is equal to the square bracket of 2, 0, 0, 0, 2, 0, 0, 0, 2, and I sub 3 is equal to square bracket of 1, 0, 0, 0, 1, 0, 0, 0, 1. Then A, B, and I sub 3 are diagonal matrices. As you can see, they are all diagonal matrices because the numbers or the natural numbers are formed in a are diagonal form or position. So we have 1, 2, 3, 2, 2, 2, and 1, 1, 1. B and I sub 3 are scalar matrices. We call them scalar matrix or matrices. And I sub 3 is a 3 by 3 identity matrix. So we call it identity matrix. It is a scalar, okay? It is a scalar. At the same time, it is a 3 by 3 identity matrix. So it's easy to show that exercise 1, that if A is any m by n matrix, then I sub n is equal to A, and I sub m times A is equal to A. Also, if A is a scalar matrix, then A is equal to R I sub n for some scalar r. Suppose that A is a square matrix. We now define the powers of matrix for P, a positive integer, by A raised to P equals A times A ellipses up to A, where these A are P factors. If A is n by n, we also define that A raised to 0 is equal to I raised to n. For non-negative integers P and Q, the familiar laws of exponent for the real numbers can also be proved for matrix multiplication with the square matrix A, where A raised to P, A raised to Q is equal to A raised to P plus Q. As we all know that when we multiply variables, we add the exponents. And quantity A raised to P, then raised to Q is equal to A raised to P times Q. It should also be noted that the rule of quantity a, b raised to p is equal to a raised to p, b raised to p does not hold for square matrices unless AB is equal to BA. An M by N matrix A is equal to the square bracket of A sub ij is called the upper triangle if A sub ij is equal to 0 for I is greater than j. It is called the lower triangle if A is sub ij is equal to 0 for I is greater than less than j. And as we all know, I is the number of rows and j is the number of column. A diagonal matrix is both upper triangular and lower triangular. So a matrix here, as you can see, A is equal to 1, 3, 3, 0, 3, 5, 0, 0, 3, and all the natural numbers are are at the top, no? So we can say that this is an upper triangular, but at the same time, this is a triangular matrices or matrix. B is equal to 1, 0, 0, 2, 3, 0, 3, 5, and 2. And as we can see in this portion, that the natural numbers in the matrix section are triangular, and specifically it is lower triangular. Definition 5.1, a matrix A with real entries is called a symmetric of if A raised to T is equal to A. A matrix A with real entries is called a skew symmetric if A raised to T is equal to negative A. Example, A is equal to quantity 1, 2, 3, 2, 4, 5, 3, 5, 6 is a symmetric matrix, while B is equal to 0, 2, 3, negative 2, 0, negative 4, negative 3, 4, 0 is a skew symmetric matrix. Based on the definition, a matrix A with real entries is called symmetric if A raised to T is equal to A. Okay, so in this portion, these are all, in letter A, are all real entries. Okay, and a matrix A with real entries is called skew symmetric if A raised to T, or the transposition of A, is equal to negative A. And this one, so that is what we call the skew symmetric matrix. Now let's talk about partition matrices. If we start out with an m by n matrix, A is equal to the square bracket of A sub ij, and then cross out some, but not all, of its row or column, we obtain a submatrix of A. Example, let A is equal to the square bracket of 1, 2, 3, 4, negative 2, 4, negative 3, 5, 3, 0, 5, and negative 3. If we cross out the second row and the third column, we get a submatrix. Tama. We can get a submatrix, right? If we will cross out the second row and the third column, we will get 1, 2, 4, 3, 0, negative 3. A matrix can be partitioned into submatrices, so that is a sample of submatrix. By drawing horizontal lines between rows and vertical lines between columns. It is very important to know this portion because we will use it in solving some determinants soon, okay? Um, in our next lesson. Okay, so of course the partitioning can be carried out in many different ways. So you can partition this matrix. Let's say I ask you to do a 2 by 3 matrices from this mother matrix. Okay, so you can just cancel some lines here, horizontal and vertical lines, to have the sub matrices or the partition of this mother matrix. Okay, so example, The matrix A, this one is A sub 11 up to A sub 45. Remember, these are not numbers na yung kinukuha. 4 means to say the fourth row and fifth column. Then is equal to A sub 11, A sub 12, A sub 21, and A sub 22 can be partitioned as indicated previously. We could also write that A is equal to A sub 11 up to A sub 45, okay, is equal to A sub 11, A sub 12, A sub 13, A sub 21, A sub 22, A sub 23, this portion, if I'm mistaken, which gives another partitioning of A with a speak of partition matrices. So, partition, pinapart-part lang nila. Okay? Getting the parts of the, big matrix. The augmented matrix of a linear system is partition matrix. Thus, if Ax equals B, we can write the augmented matrix of this system as this one, the square bracket of A, B, partition B. If A and B are both m by n matrices that are partitioned in the same way, then A plus B is produced simply by adding the corresponding sub-matrices of A and B. Similarly, if A is a partition matrix, then the scalar multiple CA or Ra is obtained by forming the scalar multiple of each sub-matrix. If A is partitioned as shown in number 1, and B is same as this from B sub 11 to B sub 54, that is equal to B sub 11, B sub 12, B sub 21, sub 22, 31, and 32, then by straightforward computations, we can show that A times B, where's that A? This one, okay? And then this B, we can have this one. Similar to the multiplication of matrices, okay? So, yun, A times B. So, we will have that kind of format in solving the multiplication of matrices. So, example, let A equals the square bracket of 1, 0, 0, 1, 1, 0, 3, negative 1, 3, 0, negative 4, 0, 1, 0, 1, 0, 3. And we will get the A11, A12, A21, A22. So this is 1, 0, 0, 1. Okay? And for this one, we will get B11 and 2B22, and that is 2, 0, 0, 1. Hanggang dito lang, di ba? This is B11, B12, 13, 14, 15, 16. This is B21, 22, 23, 24, 25, 26. B31, 32, 33, 34, 35, 36. If you know what I'm talking about. So, we have those numbers. For AB is equal to C. That is C11, C12, C21, and C22. So this is 3, 3, 6, and 12. Where C11 should be A times B, 11. Is that correct? Plus A12 and B21. Okay. So, yung makukuha dapat is 3. Let's see. Let's verify. Ito yung ano natin kanina. We have A and B. Okay. So, we have 1, 1 and I'm sorry. Saan ko ba ito nakuha? Ito yan, di ba? 1002. And this is the other group. Okay. And then for plus A12, B21. A12. Ito ba yun? A12? A21? Okay, so I think, okay, I know na. I'm sorry. I think kinat siya pala. Kinat ang ating, eto, sorry. So, this is A11, A12. Kanina ay nalilito ako. Okay, anyway, at least nakabawi. B11, B12, B21, and B22. Okay, sorry. So, yun pala sila. And for letter C naman, ito siya. Okay. So, this is C11, C12, C21, and C22. They are partitioned into 4 matrices. So, for A11, we have this one, B11, A12, B21. Multiply them, you will get this product. And multiply these two matrices, you will get this product. Add the two, you will get this sum. And this sum is similar to C11 as mentioned. So, ganon. Okay? So, example, let B is equal to 2 and 3, C is equal to 1, negative 1, 0, and D is equal to 9, 8, negative 4, 6, 7, and 5. Then, the square bracket of B and D is equal to 2, 3, and then, the partition, meron siyang line dapat dito. Ay, sorry. Alam ko may line yan. Diba yung parang augmented, may ganyan. Okay? Then, G, partition D. So, we have 2, 3, and then D is this one. Okay? Then, for DC naman, that is 9, ito yun. And then this one. Okay? So, non-singular matrices. An m by n matrix A is called non-singular or invertible if there exists an n by n matrix B such that AB is equal to BA is equal to I sub n, such as B is called the inverse of A. Otherwise, A is a singular or non-invertible. Example, let A is equal to 2, 3, 2, 2, and B is equal to negative 1, 3 over 2, 1, negative 1. Since AB is equal to BA is equal to I sub 2, we conclude that B is an inverse of A. The inverse of a matrix, if it exists, is unique. Let A is equal to the square bracket of 1, 2, 3, 4, and A raised to negative 1 exists. Let A raised to negative 1 is equal to A, B, C, D. Then we must say that A times A raised to negative 1 is equal to A, 2, 3, 4, and A, B, C, D is equal to I sub 2 is equal to 1, 0, 0, 1. So that A plus 2C, pag pinag-ano natin yan, B plus 2D, 3A plus 4C, 3B plus 4D is equal to 1, 0, 0, 1. That's according to this portion. Asan ba yun? Ito. Yan, dito. Hindi siya maguhitan. Ayan. So, in this portion, yan siya, no? So, eto yan. I hope you know paano to nakuha. 1 times A is A, 2 times C is 2C. So, di ba ina-add yan? 1 times B is 1B, 2 times D is 2D. 3 times A is 3A, 4 times C is 4C, 3 times B is 3B, 4 times D is 4D. Okay? And then that's equal, sinasabi that's that equal to I sub 2, which wherein I sub 2 is a, ang tawag kasi dito, parang symmetric. It's diagonal identity. Yan, identity matrix. So we have 1, 0, 0, 1. Di ba diagonal yung kanyang ano? Ayan. Equating corresponding quantities, these two matrices, we obtain the linear system that A plus 2Z is equal to 1, 3A plus 4C is equal to 0, 4 plus 2D is equal to 0, and 3A plus 4D is equal to 1. The solution are A is equal to negative 2, C is equal to 3 over 2, B is equal to 1, and D is equal to negative 1 half. Okay? So, paano kaya nakuha ito? That's the question. Paano nakuha si negative 2, C 3 over 2, 1, D is equal to negative 1 half? If we will try to look at here in this portion, let's say that let's say that we want to cancel this letter C. Okay, this letter C. We want to cancel letter C and we want to find ano kaya ang value ni A if you know the linear system. So let's have this one. If you know the linear system, di ba? So we want to find A. We can multiply here 2. So we have 2 times 2 is 4. Okay, negative pala. Negative 2. So negative 2 and negative 4. And then negative 2. Okay, so we have here, cancel this. Then negative 2, that's A. Negative 2A plus 3A is A. Equals negative 2 plus 0 is negative 2. That's why A is negative 2. Since we have A is negative 2, we can substitute to any of this with C. Ito na lang. So if that is negative 2, so we have A plus 2C equals 1. So A is negative 2 plus 2C equals 1. Transpose, that's positive 2. Tama? Magiging positive 2. I'm sorry. Positive 3 na siya pala. And then divide by 2. So we have 3 over 2. Correct. And for B, same thing lang yung gagawin natin. So we need to see or we need to do the elimination method to cancel blah 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 and so on as we get B and negative 1 half. Now, ito yung answer daw dito. Okay, so sinasabi dito, ayan, sinasabi dito that AB is equal to BA is equal to I sub 2. We conclude that B is an inverse of A. Ito yung A natin kanina. Asan na yun? Ayun. Ito yung A natin kanina sa example 5.10. Ay, no. Mali pala ako. Sa example number 5.11, okay? At ito yung inverse niya. Ay, yung inverse ba ang tawag na yun? Negative 1. Okay. So we have A, B, C, D. Okay, inversed. A, B, C, D. Then, we don't know this muna, di ba? We don't know the numbers. So, we just suppose that this is A, B, C, D. And then, we get the multiplication. Sabi dito, ayan, multiplication. Okay, let's say B is the inverse. And then, kumbaga, yung A raised to negative 1, siya yung inverse, no? Inverse siya eh. So, we have A and inverse of A, which is B. And then, i-multiply lang natin. And then, these numbers are equal to I sub 2. Ayan, dito yan. Is equal to I sub 2. Ayan yun, no? Yan yung sinasabi ng definition. So, ayan siya. And then, i-distribute lang natin. Parang distribution yung mga numbers na yan. So, ito yung magiging itsura niya. Magiging linear system sila. And then, after that, isosolve natin sila using elimination method. Makukuha natin value ni A is negative 2, ni C is 3 over 2, and so on. And then, using these letters from the inverse of A, which is A raised to negative 1, kukunin natin yung kanilang value from here. So we have negative 2, 3 over 2, 1, negative 1 half. At yun na yung inverse niya. And then this is equal to letter B. Yung sinasabi nga dito. Therefore, yan, yung sinasabi niya that B is called an inverse of A. Okay? Otherwise, A is called singular or non-invertible. So we have AB equals BA is equal to I sub 2. Okay? I hope you get it. If you still don't get it, you can go back with the video. So until you find it easy na lang for you to get the lesson. Okay? Now, as also satisfy the property that negative 2, 1, 3 over 2, negative 1 half, and then that is this is the inverse and this is the letter A is equal to 1, 0, 0, 1. We conclude that A is a non-singular dot, and that's A raised to negative 1 or letter B is equal to negative 2, 3 over 2, 1, negative 1 half. So parang lagi siyang may conclusion. Okay? So example, let A is equal to 1, 2, 2, and 4, and then the inverse of A exists. So let's say that this is A, B, C, D. So we multiply the two. So this we will get these quantities, and then 1, 0, 0, 1 are equal. So again, we will do a linear system. So A plus 2C is equal to 1. B plus 2D is equal to 0, 2A plus 4C is equal to 0, and 1B plus 4D is equal to 1. The linear system have no solution. So our assumption that A raised to negative 1 exists is incorrect. Thus, A is singular. So kung titignan daw natin siya, wala siyang solusyon. Paano siya magiging walang solusyon? Kapag 0 yung nakuha natin. Tignan natin. Okay, I already discussed this in lesson 1, yung no solution. So let's see. In this portion, okay, let's see, we have A plus 2C equals 1, 2A plus 4C equals 0. Okay, in this portion, let's say we need to add 2 times. So we have negative. So we have negative 2A, negative 4C equals negative 2. Unfortunately, we cancel this. We'll cancel this. 0 is equal to negative 2, and it has no solution. It has no solution, therefore it doesn't exist, and A is singular. Okay? Now, in theorem 5.2, if A and B are both non-singular n by n matrices, then AB is non-singular, and quantity AB raised to negative 1 is equal to B raised to negative 1, A raised to negative 1. Corollary 5.1, if A sub 1, A sub 2, ellipses up to A sub R are n by n non-singular matrices, then A sub 1, A sub 2, ellipses up to A sub R is non-singular, and quantity A sub 1, A sub 2, ellipses up to A sub R raised to negative 1, or the inverse of that A's is equal to the inverse of A sub R raised to A sub R, the inverse of A sub R minus 1, ellipses up to the inverse of A sub 1. Theorem 5.3, if A is a non-singular matrix, then A raised to negative 1 is non-singular, and quantity A raised to negative 1 raised to negative 1 is equal to A. It has a similarity with the transposition properties in our lesson number 4, if you still remember. Then theorem 5.4, if A is a non-singular matrix, then A raised to T, which is a transposition, is non-singular, and quantity A raised to negative 1T is equal to quantity A raised to T raised to negative 1. Okay, so these theorems are just they are just like properties that shows possibilities, no? Possibility nung mga matrices, no, na kapag ganito yung lumabas, pwede rin siya maging equal sa ganitong figure or ganitong sabihin na nating figure or system, no? Ayan, example, A is equal to 1, 2, 3, 4. Then the inverse of A is equal to negative 2, 3 over 2, 1, negative 1 half. O saan natin nakuha yun? Yun yung na-solve natin kanina. Now, A raised to negative 1 half raised to T, kukunin lang natin yung transposition yan. So, we have negative 2, 1. Ito yan. And then 3 over 2 and then negative 1 half. So, yun lang yung sinasabi ng theorem na nandito kanina. No? Nasaan ba yun? Ito, theorem 5.4. And then, also, A raised to T is equal to quantity 1, 3, 2, 4. Ito yan, no? 1, 3. So, yung 1, 2, ayan. 3, 4, ayan. No? Kinuha natin yung transposition nila. Then, yung inverse niya, inverse na nito, okay, ang gagawin lang natin is, since yung 1, yan, equal siya sa negative 2, so negative 2. Yung 2, ayan, equal siya sa 1, so 1 siya. If you know what I'm talking about here. Yung 3, tignan natin dito sa original, 3, then tignan natin dito, 3 over 2, so dito siya. 4, tignan natin dito kung saan position niya, nasa dulo, so we have negative 1 half, so dito pa rin siya. Okay? So, ganun yung sinasabi lang nung mga theorems. Another, linear system and inverses. Let the inverse of A is equal to square bracket of negative 2, 1, 3, 2, and negative 1 half. If B is equal to 8, 6, then the solution of the linear system AX equals B is X equals the inverse of A times B. So we will multiply this and you will get negative 10 and 9. On the other hand, if B is equal to... So therefore, sinasabi dito that AX equals B is equal to... Possible ba? X is equal to A raised to negative 1, B. Then B is equal to 10 and 20. If B is equal to 10 and 20, then X is equal to the inverse of A, 10, 20. And that's equal to 0 and 5. Paano siya naging 0 and 5? Get the inverse of this. Ayan siya. Negative 2, 1, 3, 2, negative 1 half. Multiply to 10 and 20. And you will get 0 and 5. I hope you already know how to do that. No? Dun sa multiplication of matrices. That's all about for the special type of matrices and partition matrices. If you still get confused regarding with this, you can go back with our previous discussion, or you can go back with these videos until you get the point of the discussion. So with that, thank you very much for your listening.